Hi guys, thank you for sticking to the main stage. We have a super interesting presentation. Don't worry, it's not going to be entirely animal themed, but still I wanted to introduce Paula Januszkiewicz, co-founder of Secure. Paula, take it away.
Yeah, thank you so much. As you can see, I'm Paula Januszkiewicz, and today I'm going to present the top 10 big little things about the infrastructure security on-premise and in the cloud. Technically, just a couple of words, of course, about myself, but then immediately we are jumping to the subject. First of all, as you can see, and not only, of course, I'm the CEO of Secure, but I'm actually the one for the past 13 years. I have established Secure that at the time, and literally 2 days ago, we have celebrated our 13th anniversary. So that's pretty awesome. And since then, we are based in 4 locations right now in the world. So New York, Dubai, Zurich, and Warsaw. And I'm Polish, so absolutely pleasure to also participate in a Polish conference, but at the same time, within our team, we are engaged in projects all around the world. I'm also a Microsoft Regional Director, but technically I'm not working for Microsoft, just to make it clear. This is an external role for someone who is engaged in cybersecurity, maybe sometimes a little bit more, but definitely this is a very honorable title for someone who is converting technology into something innovative, something working for customers. For those who are seeing me technically at the conference for the first time, just to give you a little bit of a background, within our team, which is almost 50 people right now, we are performing lots of research. We are doing the penetration tests, we are performing the incident response, but we are also doing forensics and also design cybersecurity in general for our customers. If it's about myself regarding speaking, then basically, for example, I had a chance to deliver keynote at the RSA conference in San Francisco. That's the biggest world conference in technology. I've been also rated #1 speaker at Black Hats, and speaking at Black Hats for so many years right now. And also things like Microsoft Ignite and also various other conferences where I get a chance to share our tools. And that is pretty much my only reason why we actually share details, share information, and so on. Today in the morning, you had a chance to see the presentation of Mike. Mike is our director of consulting as well. So I am actually in close cooperation with Mike. We do participate in lots of research projects, but we also do together things like incident response and forensics and so on. So Mike is also my friend. And what we're going to be talking about today? Well, first of all, we will summarize a little bit of a situation that is in cybersecurity, because we are talking about this 10 big little things about infrastructure security. So obviously we have to mention these 10. But besides that, I would have to show you a bit of a background, why actually 10, why these 10, why not something else. And that is what we're going to be starting with. First of all, what is important to mention is that workplaces, of course, especially ones that are from the regions that are hit hard by COVID-19, they were scrambling for solutions when the pandemic started. But of course, it was important for everybody to remember that cybersecurity is an important factor for remote workers. And Department of Homeland Security Cyber Agency, so that's the Cybersecurity Infrastructure Security Agency called CISA, they have actually issued an alert that was encouraging organizations to take a high-end approach to cybersecurity because pandemic is coming, so you can technically expect more to happen. So agency in this case, they cited the possibility of increased vulnerabilities, attacks, phishing attempts, and so on. And they said that, of course, this is what we can expect. And this is exactly what happened, because when we think about various reports summarizing COVID-19 and so on, we're able to see that even though COVID-19 sent shockwaves across industries, touching technically every person on the planet, then we could also see that impact happening on various operations of organizations. Like, for example, we can see that FBI reported that 300% increase in the reported cyber crimes. And that is quite shocking, I would say. But at the same time, Interpol says it's a 569%, which is also quite a lot. And that also means that cybersecurity or cybercrime needs to be a very lucrative business, because when we take into consideration the other statistic from my favorite Verizon Data Breach Investigations report, I really like this report every year because they're nice to read. This is the report summarizing 2020, because of course 2021 is not over yet, but we are learning already that 86% of breaches, they were financially motivated. And that is also quite an interesting perspective, because at that point we are able to see that whenever, of course, hacker runs a successful phishing campaign, ransomware campaign, and so on, then it brings the income on average, which is $90,000 per month. So it's a pretty nice salary, I would say, or rather very nice salary that is tempting for a lot of people to even start writing malware or to even invest in malware and wrap it into your own piece of code and then send it somehow through the phishing campaign. So long story short, whenever we are thinking about threats that are right now happening amongst organizations, then quite a big portion of those, quite a lot of them are focusing on phishing. But also at the end, we've got a code execution. We've got also things that are related with the connection to the infrastructure. So for example, we get a user using their personal devices, and then eventually that device is affected, connected to the environment, and this is how the threat is actually brought to the inside of the organization. What I really like to see, though, if it's about the summary, is that lots of organizations are investing right now into cybersecurity. So definitely we shouldn't be afraid that there will be like no job for us or something, because cybersecurity, it's a growing subject and we all know that. But also a bit of a perspective from the government. So we do cooperate with governments from lots of countries and continents as well, and we can see a very positive trend, or that is something that I'm also happy to observe, is that governments, they open up a little bit, and not only they invest into cybersecurity, not only they invest into the projects or education, but at the same time they come out of the box and they say, hey, we want to know more, where we can like see information being shared. And of course, when it's about various governments cooperating with each other, for example, in this case, from the US perspective, 76% of US state chief information security officers, they actually do believe that a centralized model can like most effectively improve the cybersecurity function. And that is something that we are able to see if it's about even organizations that were not like that before. So there is something definitely in the air. And this is what I would love to tell you, that eventually, not only there are bad things happening from the attacks perspective, but these statistics are also motivating lots of organizations to make some additional steps towards security. Now, before we start, I would like to share with you one story, because we can see over here that from the James Comey perspective, so that's he's a former FBI director, a really nice guy. 200 is a median amount of days that attackers are present on a victim's network before the detection. I've heard that that number actually increased a little bit, but regardless of the fact, we've got a pretty set number that we have to somehow decrease. And the story is very straightforward. Whenever, and that's happening this year, whenever, of course, every country was in a lockdown, we couldn't travel, and it was impossible sometimes to travel, or you got a quarantine regardless the tests and so on. So it was still at the early stage. What I could do, I could actually travel a little bit on a various government release passes that were not putting me into the quarantine. And of course, it depends why you need to do that. And one of our customers, who is actually having, let's put it this way, lots of various factories around the world, but particularly in the region of a certain country, I had to travel over there. And when that particular business goes down, they impact somewhat the economy of that country. So it was pretty important, because what happened? Well, they got, unfortunately, attacked by the ransomware, and that particular ransomware worked in a way that they encrypted their data, obviously, but the attack happened through the vendor's network. So that was also pretty interesting, because they were vendors, so IT company simply supporting that customer, and they got attacked. And because of that, they managed to get access with the in a privileged way to their infrastructure. They stayed there for approximately 3 weeks, and then they encrypted their database, where they were introducing data from the paperwork from like 1965. And unfortunately, because of the poor backup management, they couldn't do much. Now, the funny part of that is that when we came, our job was to not only figure out what happened, but also we had to, because of the situation they had, to negotiate in cooperation with the other company the rate that we are paying the hackers in order to get the data back. So we know the theory that we are not supposed to pay the hackers, blah, 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 but sometimes maybe there is no choice. And I'm not saying it's good, it's just that was the situation to deal with. So they were saying, well, nothing personal, we are just a businessman, we want money. And these guys were saying, and we want our data, so here we go. So they paid eventually €500,000, so quite a lot, for something that they got, and they got the decryptor, and that decryptor was not working. So it's a pretty expensive thing to get that it actually puts you into a situation that you are still not able to do anything. So what we did, we decompiled the decryptor, we learned how it worked, and we learned also the ways how the various pieces of data were encrypted. And then we observed one simple thing. And again, nothing new, but then yet another story confirming that simple attacks still work, because that decryptor and that encryptor, so the ransomware that we got as well, they were actually written in a very poor way. They were encrypting the first 8 megabytes of data, the rest was empty, and then the key was actually left at the end. It wasn't that simple as I'm saying, but eventually that was the logic that was applied over there. And once we learned that, and on top of that, we decompiled the decryptor and the way how things were encrypted, we were able to decrypt data manually. But how many stories like that happen? Plus, not necessarily someone needs to be happy to pay or even able to pay. So eventually we've got lots of situations from our customers during the pandemic times that confirmed that we are still not quite ready for the even advanced or maybe simple but well thought through attacks that are simply relying on, at the end, executing the code by the privileged user or by the regular user, but we don't know the code and we are still allowing that. So that is something that I wanted to share with you to give you the insight on what is actually happening right now. So whenever we are thinking about these threats, so these 10 big little sins about infrastructure security, this is something that I wanted to start with in order to demonstrate them for you. Now, first of all, it's going to be the disabling firewall. Now, again, sounds very simple, and we could say, well, cliche, nothing new. But on the other hand, what I mean by disabling firewall, it's more like misconfiguring firewall. So eventually, whenever we've got the phishing email that the user is getting, that's one thing. Then we've got a link or attachment or something to click, then user is doing that. Then that something is obviously creating a child process, usually from macro and so on. And then that child process is connecting somewhere to the hacker's infrastructure. Yeah. So that is the situation where we are allowing things that we don't know. So for example, that could be the PowerShell connecting out to connect out from the infrastructure to the unknown location. And that's why I'm a big fan of, in general, not only, of course, application allow listing / whitelisting, but I'm a big fan of also putting on the top of that a firewall where we block all the outgoing traffic and then we only allow the traffic from the components that we know. And this is how, for example, from the ransomware perspective, the solution that is executing on someone's computer is not able to simply reach the place. And this is what we got. So therefore, I would like to show you the first demonstration, which is going to be pretty straightforward, a small warm-up related with the situation here. On the hacker side, we are just listening. Yeah, so that's basically the netcat, and on the right side of the you can see that I've got an email, and within this particular email, we've got a macro, so we can just open it up. That's the XLSM. Yep, so that is the setup. Yep, let's do that. And then eventually we've got here the possibility to run that particular macro. So we're going to do enable editing, enable content. We all know that users can also do that. And then eventually in the name of user, we're running here the reverse shell. And that reverse shell, it's actually written by our team. It's a reverse shell that is not recognized by vast majority of the antivirus solutions because of our custom reflection technique that we use over there. Anyway, so it's actually a pretty simple macro. We are here using as well the low bus load bin, so certutil, classic thing, the code. We are decoding the txt file into the executable, and then eventually we are creating the process within this particular shell. Now, on the side of Kali Linux, we've got access to the user's computer, so nothing outstanding. But what we can do at that point, being, of course, who we are, you can verify what kind of privileges we got, and we are able to see that that is actually a regular user. So the next part is going to be, of course, to verify what kind of possibilities we got if it's about the escalation. And regarding the situation that we might have, we can search for various misconfigurations and so on. I'm going to use over here the privilege escalation script that is going to allow me to actually use that possibility within operating system to actually escalate myself to the higher privileges. This is, by the way, the publicly available script, which I'm happy to share. So again, we are able, of course, to use the vulnerability over here. So this is the DLL hijacking that we are leveraging, and eventually you are able to do that under the name of the user. Yeah. So as you can see, loaded by the task scheduler, app on service startup, and so on. Yeah. So long story short, that's one of the possibilities. Yeah, one of the possibilities. So that's why, depending on the situation we're going to be in, which I will show you in a moment, we'll be able also to do even more over here. And then at that moment, we're going to simply put in the reverse.dll, and then that will be the DLL that we're going to be executing over here, and we are just simply changing it. And then the next part is that we're going to be, of course, running it. We are able to see that that DLL is already there. Yeah. And then at the moment where we're going to be executing various other things, then we will be able to just simply use this particular DLL. Yeah. So we can reset that particular machine, and then at the moment, of course, that machine is going to be rebooting. We're going to be waiting here for the incoming connection. And then the next part is that the service is going to start, and the service is going to run the DLL that's going to be connecting back to the hacker. So it's a misconfiguration situation. Yeah. Now, eventually, depending, of course, where we are able to write and what kind of possibilities we got in the terms of services, yeah, here we are able to see that we're going to be the anti-authority system, which creates us a huge set of opportunities for the next attacks. So one of the situations, of course, it doesn't have to go this way. It might go also in a way where we have only access as a user, like I had before. Yeah, so we could even stop over there without any kind of privilege escalation situation. So misuse of credentials, because eventually when we are already on the hacker's in a hacker's skin, and at the same time sitting on the user's desktop, we've got a possibility to extract passwords as a user, meaning that if the user stored some password, for example, in the browser and so on, then we've got a possibility actually to extract them if we are these users. Now again, very common thing to leverage within the attack. That's why I'm putting that as a sin, because people in the organization should not do that. They should be rather trained for using, for example, things like KeePass and so on. And this is what we see as well amongst our customers, for example, banks, that there are these campaigns happening that are encouraging or sometimes enforcing of usage of the KeePass in the organization, and that's great. And the reason why it's like this is because if we do have a situation where, of course, we store the password in a browser, then, for example, that's particularly for Google Chrome, we are able to extract it. This is Nearsoft, of course. It's again publicly available app. I'll just cancel this because my machine has no network communication here. And eventually, we are able to see that that's the password in the clear text. Now, what I would love to show you, by the way, it's one thing here, is that if the user stores in general password in the browser like this or in any other really application, what we are leveraging over here, it's something that's called data protection API. And data protection API, it's something that is, to be sincere, one of my favorite subjects, because this is something that our team, as far as we know, we are the only ones and the first ones in the world that reverse engineer that. We spent over 2 years on the top of that. And there are a couple of things that I would have to show you that you guys definitely need to take into consideration if you did not already. So we've got a couple of things. So Freddy has stored password in the browser. We can see it. Yeah. So that's the password, whatever. Now, question is, who else is capable to extract password in the name of Freddy? One, it's going to be someone who knows the password of Freddy, because if you are Freddy, then data protection API, so the cryptographic platform of Windows, works in a way that it allows you to actually extract passwords of the user for in this case domain user if you know the user's password. So technically, if you know the user's either password or hash, so MD4. Yeah. For the case of a local user, the story is a little bit different, because in this case you need to know the password of the user or SHA-1 of the password of the user. Yeah, so these are the things that are required here. That's why using hibernation in general in both of the cases is not a very good idea, because it stores the hashes within the memory, including SHA-1 for the local user. So not a good thing to use. But what if we are a classic user in the domain? Yeah, then what kind of possibilities we got? So see, what I would love to show you is first that I'm gonna disconnect this machine from the even internal network. So here we go. What kind of possibilities we got is that we are able, as someone who has appropriate privilege within the domain, to extract passwords that are privately saved by every single user in the domain. So this is something that I would love to here show you. First of all, what we're going to do, we're going to boot from the ISO image. I could do this demo without that step, but with this step, it's a little bit easier to demonstrate what is actually happening here. So we're going to do it this way. It's a little bit easier to explain, more linear and more logical steps over here. And what we're going to do, first of all, I'm going to here override cache logon data. Some people call it cache credentials. It's a very bad thing. I really don't like it, because these things are not credentials. This is just cache logon data. We cannot log on with those. We can only compare with those. So here we go. Troubleshoot advanced options, command prompt. And then over here, I'm going to do one thing, D drive. And then let's go to the CQ tools. And we've got here Kiwi Secure Edition. Mimicuts, we all know. This is, of course, a tool by Benjamin Delpy. We cooperate with Benjamin. This is our secure edition. Again, if you drop it to VirusTotal, it's going to be green. It's not recognized by antivirus. So eventually, what we will need to do is to override cache logon data. Why? Because I would love to log in with a different password to show you that these secrets of the Google Chrome and some other apps are dependent on our password. Okay, so we're gonna do it this way. So we get a LSA dump cache, and then we got a D Windows system. Unfortunately, I cannot type. I have to type it. System32 config system, and then D Windows system32 config security, because this is where we've got the cache logon data / Kiwi. It is something that allows us to override that cache logon data. This is, by the way, our module that does this here. Okay, so we got that, and this is all overwritten. Network is disconnected, so we are ready to log in with that changed password. But what kind of password? Because I didn't really type it, right? The password is going to be Mimicuts. The tool automatically sets up the password, sets up the value in the registry that whenever we put the password Mimicuts, and when we compare, that's going to let us in. So it's actually quite simple mechanism here. So here we've got password that I was originally using before. As you can see, I'm not able to log in to the domain user. Then Mimicuts, here you can see that I'm actually logging on as this domain user. Just to give you a little bit of a background, because cache logon data always requires a bit of an explanation, and I'm going to use Notepad for that before we get into some other steps here. Cache logon data, by the way, we call MSDCC2, and underneath there's actually the use of a function which is called pbkdf2. It's a publicly known function. It's not like Microsoft. It's used by lots of companies. To be fair, of course, happy to give you more details about it. But pbkdf2 in the Microsoft case for that particular use case is using the first of all hmug schwa1. And that's basically, let's say it's going to be like a random value over here plus username, plus it actually uses DCC1, and I'm going to explain what's DCC1 in a moment. And then DCC1 that we've got here as well, 10,240 iterations on 16 blocks. So it's not reversible. That's one thing. Second, the only thing you can hit this, it's by leveraging the brute force or rainbow tables that are generated for the pbkdf2. So here we go, yeah? Or for, in general, MSDCC2 value. DCC1 has been used down to Windows XP. So Windows XP was the last operating system that leveraged that. And that's good news because it actually is built up this way. So we get an MD4 on the top of the username joined with MD4 on the top of the password. So it's like John E19, blah, 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 blah. And on the top of that, we've got MD4. So imagine that is only a part of a function. So that's quite a complex mechanism, which in general, it's hard to crack. And for the 2 days day, it is actually considered to be safe. Okay, so we got this. Nice. So the next part, it's going to be to verify whether we got access or not. And as you would expect, we won't be able to access a password because we logged in with the password mimikatz, and that is exactly what's happening here. But the problem is that data protection API in the enterprise is as safe as your privileged accounts are. So for example, as your domain admin is, as your in general privilege access is, but to be precise, as your 2 permissions on the top of the domains are, that is replicating directory changes and replicating directory changes all. Yet these 2, they have to be reviewed, plus of course privilege access as well. But long story short, whenever we got that kind of situation, why do we even like connect over here some privilege access from the domain? Well, it is pretty straightforward. What if I told you that in general, whoever has these particular permissions in the domain is capable to read everybody's passwords, everybody's secrets in the whole organization? So if you work in a bank and so on, then you are probably dealing with lots of users, and that is the situation that we want from the hacker's perspective. So let's see how we are able to decrypt these secrets for all of the users within the domain. Okay, so it's going to be the setup. So I'm going to get into the toolkit. That's the CQLSS secrets number. This is our tool to work on a domain for the data protection API for the whole cryptography platform. And then the next part is going to be the file, exported, PFX, enter, and that's it. And that exported PFX, as you see, it's a PFX. So we are dealing with some kind of a keys. I can import. Yeah, password over here is going to be secure. Yeah, so here we go. CQRE. Next. I don't have to import it, but I just want to show you. Yeah, so cert mgr.msc. Here, everybody who has domain, then you guys have that kind of certificate there. You want it or not, you do. Yeah. So if you have set up your domain like long time ago, then you do see the certificate out there that being dated within the year that you have set up your domain. So if you set up your domain in 2012, then this certificate is already expired. Can you change it? No. Can you rise the functional level? No. Can you? No. You cannot change it. That's how it is, unfortunately. So when this certificate leaks, because you are not able to find it in a cert store, it's actually a part of ntds.dit. When this certificate leaks, you're really having a big deal because eventually that certificate allows to get access to everybody's secrets within a domain. And if it leaks, you cannot renew it. So if you got an attack on the domain controller, like some of our customers had, what can you do? There is a procedure of over 40 steps to execute to fix this problem, but there's one thing that you cannot fix. You cannot get that certificate renewed. So what I'm trying to say is that if you ever had domain admin and that domain admin is no longer working with you or still working, but it might be not a very trustworthy person, can we say that our infrastructure has been already compromised? Absolutely. And I really like to say that because that certificate, as we mentioned, when it leaks, you are not able to fix this problem. So any domain admin had access to that certificate. And if it leaks, they can be reading secrets of your employees till the end of the world until you change the domain. And that is what we are dealing with. So it's actually quite a big thing. So how we are able to leverage that certificate on a client? I'm going to do it over here. So let's do that. First of all, we're going to get into the CQ tools, DP API. I'm going to first calculate over here the passwords hash, so the MD4 on the top of the mimikatz, yeah? And then we're going to do it this way. We're going to get into the CQ DP API blob searcher to find which particularly master key, so within the data protection API we use encryption keys, is responsible at that point for the decryption of the secrets. And in this case, I'm going to use the D parameter. So C users for folder, Freddy Krueger, and it's going to be update local Google. We're going to go directly to Chrome. And the next part is the recursive search and output to see CQ tools and stream it to dpapi.txt. Awesome. Yep. And the next part, it takes approximately 20 seconds. We're going to be here reading dpapi, which is the master key responsible for protection of the secrets in a Google Chrome. And what we are seeing over here is that there is SHA-1 triple des engaged in Google Chrome. But let's say it's a good, I mean, it's still cryptographically considered a good solution, so I'm not gonna comment on that, but it's not a very good choice, as we all know. But anyway, we're gonna B5580, yeah? So that B5580, it's the identifier of the key that's used by the Google Chrome in my system. In yours, it's gonna be something else. But within our tool, which is CQDP API Blob Searcher, you can figure it out. By the way, it's my favorite tool in our team. It's super useful for forensics. You're not able to find that information in any forensic book, so it's actually pretty cool. Anyway, the next part is gonna be also pretty straightforward because we're gonna, knowing by that's B55, we're gonna generate the command, so master key AD, where we're gonna be decrypting the that master key that was encrypted with the user's passwords hash with our PFX. So we're going to do it like this. PFX, here we're going to do exported PFX, new hash, we are going to paste it. And then the last one, file, we're getting into this B55. Where is it? Percent, updata, percent, Microsoft, protect, SID. This is, by the way, system and hidden. So if you want to see it, you have to switch that on. Don't forget. So here, B55, and we're going to take this, shift right click, and then copy as path. Lovely. And we are pasting it here. So we are decrypting it and encrypting it again. Yeah, so we got this. And then one more thing, there's this new key created. So I'm going to do a little bit of a rename here. Let's name it something nice, like good or something. And this one we are replacing. So this one should give us access to our passwords. That will be lovely. And one more thing, because you can see the icon is really strange. We will need to give it an attribute of a system and hidden here. Okay, so I'm going to run this command. We are generating it automatically for comfort. And then I can get in here and then refresh it. And you can see that we are getting access to the Freddy's password, which, by the way, it's really serious in consequences, because it means that you are able to do that for every single user in your domain, for any application that you are using that's leveraging DP API. I'm not saying DP API is bad, because it's not. It's actually great, but password management is bad, and that is what we are referring to. Okay, so we showed over here like lots of things. Now, Now, another part, it's no network segmentation. So no network segmentation, just to mention, that is in the context of the VPN pivoting attack, where we are able to technically be on the user's computer. So it's the same position that we were in all the time. So hacker is already connected to the user's computer, and then we are connecting through the user's computer to the inside of the organization. So that's why no network segmentation, because users not supposed to see some sensitive components of our infrastructure. And if they do, then they can leverage shadow IT and start attacks like this. So SMB relay, very straightforward, very simple attack. To be sincere, my favorite, when I'm doing the pen test, I'm always starting with this one because this is an attack that always works, and it's relying on the case where SMB is not signed, which is default, and also the NTLM version 2, the protocol which is used for authentication. And if we get a chance, we should avoid that. Yeah. So I'm not again saying that Kerberos is the greatest choice, because Kerberos has its own issues too. For example, we've got a Kerberos attack where we are able to request for the particular ticket that we are able to crack later. But then it's a little bit better if it's about how to get access to it versus NTLM version 2 and SMB relay all together. This is an attack, by the way, that I'm demonstrating on our blog, secureacademy.com/blog, so you can jump over and see, because there's like a full demonstration of the attack, how to do that. But we still see that as a problem because it is something that technically just easily happens. Now, allowing unusual code execution in two ways. So here you've got the common file formats containing malware, or in general some malicious stuff that could execute, but at the same time we've got also the possibility to execute the code in the way through the macro. Therefore, for example, one of the things that we are always recommending to our customers, having phishing as a number one mean of transportation for malware, it's something that we call attack surface reduction rules, and that is something that we are able to, for free, implement in Windows boxes underneath. And for example, disallow running the child processes from Office. Or, for example, disallow the Win32 API calls and so on. So quite an advanced setting that are allowing us to minimize the risk for coming of the various attacks through the phishing attempts. So we've got that part. Now, another part is that we've got no whitelisting on board, and that's kind of like a second part of it. So it means that, first of all, we are allowing, for example, the PowerShell to execute and so on in a certain way, but at the same time, globally looking at it, whitelisting is another part. So yeah, simple thing, not much to explain really over here. Lots of our customers, or future customers, so to say, they do not have that one on board, meaning that we are able to execute the code that we don't know, also as privileged users. Another part to cover, and that's number 7, old protocols or their default settings. One of the things that I really like over here to touch base on, it's the TDS. And TDS, it's a tabular data stream. It means that you are able to capture the traffic in between the SQL Server and the clients. And that traffic tabular data stream, it's by default in a clear text, unfortunately. So that is something that we always advise over here to review. If you got an encryption for the connection implemented on the level of SQL, because by default, that kind of stuff, so queries to the database and so on, their replies are actually happening in the clear text. And another part, it's trusting solutions without knowing how to break them. And that means, for example, whether we are able, let's say, to stop an antivirus or not, whether we are able, for example, to use some solutions that are appropriately working, and do we think that what we got is what we are supposed to be getting within this particular solution. Now, what I would love to show you is actually one funny thing over here, and that is quite a simple demonstration, but also in the flavor of what we see. That is actually the Sysmon, which I'm a huge fan of. I love Sysmon, but Sysmon as well, we shouldn't forget, it's a mini filter driver. And if we run the build on Windows tool, FLT MC, we here see that sysmon is there, sysmon driver. Yeah. Now sysmon driver technically can be unloaded. So if we do FLTMC and then whatever question mark, yeah, then we are able to see that we are able to unload it. Yeah. So load, unload, and then attach, detach. So first, if we do FLTMC instances, we've got sysmon driver attached to the C drive. Okay, so we're gonna do FLTMC detach. Yeah. So let's do that. FLTMC detach, and then we are detaching the sysmon driver from the C drive. And then if we do FLTMC instances, then you can see that sysmon driver is no longer monitoring the C drive. Awesome, right? But at the same time, if we do FLTMC again, sysmon is running. So maybe we should just unload it. Unload sysmon driver. Okay, what about now? FLTMC, it's no longer there. Okay, so we're going to do st query and then sysmon driver running. So the problem here, it's quite big because we are trusting the solution, showing us that there is this situation that the sysmon is running, but at the same time, there is quite a big issue. Misusing service accounts and privilege accounts. So it's a case of a privilege access and service accounts being very often misused for the attacks. And also the last one, failing for hipster tools, that sometimes we are allowing our employees to run something, or we choose some solutions that we haven't checked really in details. And at the same time, that might be a big deal. And I'm not saying that SolarWinds is a hipster tool, but we know the story. So when we are using some tools, then at the same time, we should have an appropriate level of monitoring. However obvious that sounds, monitoring privilege access and identity, it is actually more important than ever. Summarizing best practices, well, first of all, configuration reviews, context-aware analysis. So what things are seen from certain perspectives, what people see when they are users, and so on. That is also quite a new trend that we are observing at our customer sites. Having a well-implemented incident response plan, and also having a way to escalate that plan quickly. So if something happens, you need to know what to do, because we've seen too many cases where customers did not, and then that actually led to various issues. Download the tools, resources, secureacademy.com/tools. And of course, don't forget to check our blog, which is secureacademy.com/blog. And if you would like to be in touch with our team and myself, this is the slide where you can see the email, paula@secure.pl or paula@secure.us. So thank you so much for listening. Hopefully it was insightful, short, but quite intense. So I'm giving the stage back to you, Matej. And if you guys have any questions, then don't hesitate to ask them too.
Perfect, Paula. Thank you very much. This was very insightful, and you filled the space with very exciting and interesting examples. So I will route those questions to your contact details, as we can see on this slide. Thank you very much for joining, and stay safe. Good luck with everything.
With stuff.
Yes.
Thanks so much, Matej, and thank you guys for listening, and have a great day.